Let's take a look at this problem. I know this may not be exactly one you're asking about, but this should give you the idea. 2 over x minus 5 minus x plus 2 over 25 minus x squared plus 3x minus 2 over 25 plus 10x plus x squared. Now first off, these are not in standard form, so I need to put them in standard form. And what I'm talking about there is the denominators. So this 25 minus x squared, I'll rewrite as negative x squared plus 25. It needs to go from largest power down to smallest. Plus 3x minus 2, and I'll rewrite this. This is x squared plus 10x plus 25. Now we need to get a common denominator. And in order to do that, we're going to factor all of our denominators. Well, this negative x squared plus 25 is GCF. Because remember, if your first term is negative, you always bring out a negative. And this next one, the x squared plus 10x plus 25, is PSD. So this becomes 2 over x minus 5 minus x plus 2 over negative, and then x squared minus 25. Plus 3x minus 2 over x plus 5 times x plus 5. Now I can still do some more factoring here. This is difference 2 squares. 2 terms of the minus trinket. So I got 2 over x minus 5. Now here we got a negative negative. I could take this negative on the bottom and put it out in front, and then that becomes a positive. X plus 2 over x squared minus 25 becomes x plus 5 times x minus 5. Plus 3x minus 2 over x plus 5, x plus 5. Now we have to figure out what our least common denominator is, and then rewrite each fraction with that new denominator. Okay. We'll start with our first factor, the x minus 5. Now I'm looking for the greatest number of x minus 5s in a single denominator. There's one here, there's one here, there's none here. So our greatest number of x minus 5s in a single denominator is 1. Now we'll go to our next factor, which is x plus 5. And we'll look for the greatest number of x plus 5s in a single denominator. There's none here, there's one here, there's 2 of them here. So the greatest number of x plus 5s in a single denominator is 2 of them. So that's going to be our common denominator. So let me go ahead and write it in all my denominators. Now we have to look at what new item has been put down below. This first fraction had an x minus 5, that's still there. The new items are the x plus 5 and the x plus 5. Whatever new items you have down here, you put up on top. So that'll be x plus 5, and that'll be x plus 5. The mathematical principle behind that is whatever you multiply by the denominator, you have to multiply by the numerator. On our second fraction, we had an x plus 5, that x plus 5 is still there. We had an x minus 5, that x minus 5 is still there. The new item down below is this x plus 5. So we'll put that up on top. Now our last fraction. It had an x plus 5, that x plus 5 is still there. It had another x plus 5, that x plus 5 is still there. The new item is the x minus 5. So I'll put that up on top. Whatever new item you have down here, you have to put up on top. Okay, well, we'll get rid of parentheses. X times x is x squared. X times 5 is 5x. 5 times x is 5x. 5 times 5 is 25. over our denominator. Now I'm not going to write denominator. I'll put it back in at the end. Plus, FOIL these also. X times x is x squared. X times 5 is 5x. 2 times x is 2x. 2 times 5 is 10. All over our denominator. And FOIL these. 3x times x is 3x squared. 3x times negative 5 is negative 15x. Negative 2 times x is negative 2x. Negative 2 times negative 5 is positive 10. All over our denominator. Here we got 5x plus 5x is 10x. Plus 25 over our denominator. Plus x squared. 5x plus 2x is 7x. Plus 10 over our denominator. Plus 3x squared, negative 15x, negative 2x is negative 17x, plus 10 over our denominator. Well, now I'll multiply the 2 through. 2 times x squared is 2x squared, distributive property. 2 times 10x is 20x. 2 times 25 is 50, over squiggly, plus x squared plus 7x plus 10 over squiggly, plus 3x squared minus 17x plus 10 over squiggly. Well, they all have the same denominator now, so now we're going to merge together the top parts, adding them. So we're going to have 2x squared plus 20x plus 50 plus x squared plus 7x plus 10 plus 3x squared minus 17x plus 10 all over our denominator. I'll put that back here shortly. Now combining together like terms, here's an x squared, here's an x squared, and here's an x squared. You add or subtract the numbers in front of them. 2 plus, there's an invisible 1 here. 2 plus 1 is 3, plus another 3 is 6. So that's 6x squared. Here's an x, and here's an x. 20x plus 7x is 27x, minus 17x is 10x. Here's a number, and here's a number. 50 plus 10 is 70. Over x minus 5, x plus 5, times x plus 5. I see I can factor out a GCF up on top. I think just 2. So that gives us 3x squared plus 5x plus 35 over our denominator. I'm not seeing it, but let's see. That would be the key number if I could factor it. So I take the number at the beginning times the number at the end, ignoring signs. That's going to give us 105. I got 1 times 105. I got 3 times 35. 4, no. 5 times 21. 6, no. 7 times something. 7 times is 7, 35. 7 times 15. 8, no. 9, no. 10, no. 11, no. 12, no. So that looks like it. And I don't see anything that added or subtracted gives us the 5. So that means it doesn't factor anymore. I'm not sure how they're wanting the answer. It doesn't say. Let's see. So I got 2 times 3x squared plus 5x. I just want to make sure I got the correct answer. Plus 35 over x minus 5 and x plus 5 squared. Okay. And that's how you'd work on that particular problem.